there is a sound in the universe that no one can hear. A flash so bright, so violent, it outshines entire galaxies. A beam of pure energy, piercing through space and time like a cosmic lighthouse, but one that only burns for seconds or minutes before vanishing forever. It's called a gamma ray burst, and it is the most powerful explosion known to science. Not supernova, not black holes colliding, not even the Big Bang itself released energy so concentrated, so focused, so terrifyingly efficient. In the blink of an eye, a gamma ray burst can release more energy than our sun will in its entire 10 billion year lifespan. And yet, we only discovered them by accident. This is the story of the universe's ultimate fireworks. Imagine you're a soldier during the Cold War, scanning the skies, not for stars, but for nuclear missiles. It's the late 1960s. The United States has launched a series of satellites, not to study space, but to catch the Soviet Union breaking the Nuclear Test Ban Treaty. These satellites, part of the Vela program, are designed to detect gamma rays, the signature radiation of atomic explosions. But in 1967, something strange happens. One of the satellites picks up a burst of gamma rays, coming not from Earth, but from deep space. No missile, no warhead, just energy, a flash from nowhere. Scientists are baffled. They check the data again and again. The signal is real, and it's not alone. Over the next few years, they detect more, 16 in total, all arriving from random directions in the sky. Some last just milliseconds, others go on for minutes, but each one is unimaginably powerful. They name it gamma ray burst. But no one knows what causes it. Is it neutron stars colliding, stars collapsing, or something older, something we haven't even imagined? For decades, it remains one of astronomy's greatest mysteries. Until one night in 1997, everything changes. February 28th, 1997. A gamma ray burst detonates in the far reaches of space. This time, a satellite called Beppo-SAX doesn't just detect the burst, it locks onto its position within hours. And within a day, ground-based telescopes swing into action. They find something extraordinary. Not just a flash of gamma rays, but a glowing afterglow. A fading ember in the visible spectrum, lingering like smoke after an explosion. And from that afterglow, astronomers calculate the distance. They nearly fall out of their chairs. This burst came from a galaxy 6 billion light years away. 6 billion. That means the light, the energy, had been traveling since before Earth even existed. And yet, when it arrived, it was so bright, it briefly outshone everything in the night sky, except the moon. All from an explosion so distant, so ancient, that by the time its light reached us, forests had grown, dinosaurs had risen and fallen, and humans had just begun to walk the Earth. And in that moment, scientists realized they weren't just witnessing a flash. They were seeing the death scream of a star, or the violent birth of a black hole, or the collision of two dead stars spiraling into each other faster and faster until they merged in a cataclysm that tore open the fabric of space. Gamma ray bursts are not just powerful, they are universe-altering events. Let's take a closer look. There are two main types of gamma ray bursts. The first are the long ones. They last more than 2 seconds, sometimes up to several minutes. And they are linked to the deaths of massive stars, stars many times heavier than our sun. Imagine a star, 20, 30, even 100 times more massive than our own. It burns through its fuel at a furious rate, living fast, dying young. After just a few million years, a blink in cosmic time, it runs out of hydrogen to fuse. The core collapses under its own gravity. And if the star is massive enough, that collapse doesn't stop. It doesn't form a neutron star. It keeps going, crushing matter beyond all known limits, until it becomes a black hole. Now, here's where things get wild. As the core collapses, it begins to spin faster and faster, like a figure skater pulling in their arms. And in that violent spin, twin jets of energy, unimaginably powerful, blast out from the poles of the dying star, traveling at 99.99% the speed of light. These jets punch through the outer layers of the star like a bullet through tissue paper, and when they finally break free, they release a beam of pure gamma radiation, the most energetic form of light in the universe. That is a long gamma ray burst. And if one of those beams were pointed directly at Earth, even from thousands of light years away, it could strip our atmosphere, trigger mass extinctions, or worse. But don't panic. The odds are astronomically low. And besides, most of these bursts happen in distant galaxies, far beyond our cosmic neighborhood. Still, the power is staggering. For a few seconds, one of these bursts can outshine everything else in the observable universe combined. Now, the second type are the short gamma ray bursts. They last less than 2 seconds, sometimes just milliseconds, and for years they were a mystery. Until 2017. That year, something incredible happened. 2 neutron stars, city-sized remnants of dead stars, so dense that a teaspoon of their material would weigh 1 billion tons, spiraled toward each other, faster and faster, until they collided. The collision sent gravitational waves rippling across the universe, like ripples in a pond. And when those waves reached Earth, they were detected by LIGO, the Laser Interferometer Gravitational Wave Observatory. But that wasn't all. Within seconds, satellites detected a short gamma ray burst coming from the same region of sky. For the first time ever, scientists had witnessed the birth of a short gamma ray burst in real time. It was like watching a cosmic crime scene unfold with multiple cameras, and what they saw changed everything. The merger of 2 neutron stars didn't just produce gamma rays. It also created a kilonova, a rare type of explosion that forges heavy elements like gold, platinum, and uranium. Yes, the gold in your wedding ring, the platinum in your car's catalytic converter, may have been forged in the heart of a neutron star collision billions of years ago in a distant galaxy. And it all started with a burst of gamma rays lasting less than a second. Can you believe that? The universe is not just violent, it is creative. Destruction and creation are 2 sides of the same cosmic coin. Now, let's talk about what gamma ray bursts mean for life in the universe. Could one have caused a mass extinction on Earth? Some scientists think yes. There's a theory, still debated, that a gamma ray burst from a nearby galaxy may have triggered the Ordovician extinction around 440 million years ago. That event wiped out nearly 85% of marine species. How? If a burst is close enough and pointed at Earth, its gamma rays would hit our upper atmosphere, breaking apart nitrogen and oxygen molecules. This would create a thick layer of nitrogen dioxide, turning the sky brown, blocking sunlight, and triggering a rapid ice age. At the same time, the ozone layer would be destroyed, exposing life to deadly ultraviolet radiation from the sun. The result? A 1-2 punch of cold and radiation. Perfect conditions for a mass extinction. Now, this is still a hypothesis, but it's a chilling reminder that even in the quiet of space, danger can come from unimaginable distances. And yet, here we are, alive, aware, looking up and asking questions. Because of gamma ray bursts, we now understand more about black holes, neutron stars, the formation of heavy elements, and the extreme physics that govern the universe. We've learned that the cosmos is not a static place, but a dynamic, violent, and breathtakingly beautiful theater of energy and transformation. Every burst is a message, a signal from the edge of time, telling us about the life and death of stars, the birth of black holes, and the alchemy of the elements. And thanks to satellites like Swift and Fermi, we now detect a gamma ray burst almost every single day, one per day. Somewhere in the universe, a star dies, or two neutron stars collide, and for a brief moment, the sky lights up with the most powerful explosion since the Big Bang. And we, on this tiny blue planet, are watching, listening, learning. Now, let's imagine witnessing one of these bursts up close, not from billions of light years away, but from just a few thousand. What would happen? First, you wouldn't see the gamma rays. They're invisible, but the moment they hit the atmosphere, the sky would ignite, not with fire, but with light. A second sun, appearing in the sky, brighter than anything you've ever seen. Then, silence. The burst lasts only seconds, but the damage is already done. High-energy radiation strips electrons from atoms, creating a cascade of charged particles. Radio signals fail. Satellites fry. Power grids collapse. And high above, the ozone layer begins to dissolve. Within weeks, the planet cools. Clouds turn brown. The oceans acidify. Life on the surface struggles. And if the burst lasted longer or was closer, it could end everything. But again, the odds are incredibly small. The nearest candidate for a long gamma ray burst, a star called WR1004, is about 8,000 light years away. And even then, we don't know if its jets are aimed at us. So, while it's a dramatic scenario, it's not something to lose sleep over. Far more likely is that gamma ray bursts are simply part of the universe's natural rhythm. Like thunder after lightning or waves after a storm, they are the echoes of creation, written in energy and light. Now, let's go deeper. What do gamma ray bursts tell us about the early universe? Some of the most distant bursts we've detected come from when the universe was less than 1 billion years old. Back then, galaxies were smaller, stars were more massive, and the cosmos was a wilder place. These ancient bursts are like time machines. They allow us to study the conditions of the infant universe and how the first stars lived and died. One burst, GRB 090423, exploded when the universe was just 630 million years old. Its light traveled for over 13 billion years before finally reaching our telescopes. When we observe it, we're seeing a moment just after the cosmic dark ages, when the first lights began to shine. Another burst, GRB 089113, helped confirm that heavy elements existed much earlier than expected, suggesting that neutron star mergers were already happening when the universe was still young. Each burst is a clue, a breadcrumb leading us deeper into the story of everything. And the more we learn, the more we realize how interconnected it all is. The iron in your blood, the calcium in your bones, the oxygen you breathe were forged in the hearts of stars. And the gold in your jewelry, likely born in the collision of two neutron stars seen across the cosmos as a fleeting burst of gamma rays. Is that not poetic? The universe doesn't just make stars and planets. It makes storytellers, beings who look up and wonder, who piece together the clues, written in light and time, and who, against all odds, survive to tell the tale. So what have we learned? Gamma ray bursts are the most powerful explosions in the universe. They come in two types, long and short, linked to the deaths of massive stars and the collisions of neutron stars. They can outshine entire galaxies, release more energy than the sun will in its lifetime, and forge the heaviest elements in existence. They are rare, distant, and usually harmless to Earth. But they are also messengers, bringing us news from the edge. of space and time. From the birth of black holes to the chemistry of life itself, and every time one goes off, somewhere in the sky, we point our telescopes and listen. Because in that flash is a story of destruction, transformation, and the relentless creativity of the cosmos. So, the next time you look up at the night sky and see the stars, remember this. Some of those stars are already dead. Their final moments may have ended in a beam of gamma rays shooting across the universe, even now, on its way to us. And one day, when it arrives, we'll be ready, watching, listening, and marveling at the most violent and beautiful fireworks in existence. This is the story of gamma ray bursts. Powerful, mysterious, cosmic, and proof that even in the darkest corners of space, light always finds a way.